Have you ever just stopped and wondered how our digital world actually works? You know, how an app remembers your shopping cart, your profile, your order history, all without skipping a beat? Well, it's not magic. It's architecture. And today, we're going to pull back the curtain on the blueprint that makes it all possible, the entity relationship model.
I mean, really think about it for a second. When you place an order online, how does that system possibly know which items go into your cart, connect that cart to your payment info, and then link it all to your specific address out of literally millions of other people? That is the exact question we're going to answer.
And the answer is a really smart and careful design called an entity relationship model. You can think of it as the blueprint database designers use to map out exactly how information is going to be structured and connected before they even write a single line of code. This planning stage is absolutely crucial. It's what prevents total data chaos and makes sure systems can grow without falling apart.
So, the most basic building block of this whole blueprint is something called an entity, and it's way simpler than it sounds. An entity is just a thing or a concept that we care about and want to track. In our online store example, the main things are pretty obvious, right? We have the customer who's buying, the product that's being sold, and the order that brings them together. These are our fundamental pieces.
Okay, so we have our things, our entities. We've got customers, products, and orders. But you know, just a long list of customers and a long list of products isn't all that useful by itself. The real power, the magic, happens when we start connecting those dots. And that brings us to the second core idea, relationships.
That connection is called a relationship. If you think of entities as the nouns in our data sentence, then relationships are the verbs. They describe the action. A customer places an order. An order contains a product. These are the crucial links that give our data its structure and its meaning.
Now, not all relationships are created equal. They're actually defined by their degree, which is just a fancy way of saying how many types of entities they connect. The first is a unary relationship. This is a weird one, where an entity has a relationship with itself. For example, in a company, an employee can supervise another employee. It's just one entity type, employee, but it's playing two different roles in that relationship.
Next up, and this is the one you'll see pretty much all the time, is the binary relationship. This is a link between two different entities, like a customer and an order. This is the real bread and butter of most database designs, and it's the main one we're going to be focused on for our online store.
And just to show you how far this can go, you can also have ternary relationships, which link three entities all at once. For instance, think about a university. A professor teaches a subject, but only in a specific class. You need all three of those pieces, the professor, the subject, and the class, for that connection to make any sense.
Okay, so having these connections is great, but it's not enough. We need rules. You can't just connect things willy-nilly. We can't have an order that doesn't belong to a customer, right? That would be chaos. These rules are defined by something called cardinality, which basically just tells us how many of one thing can be related to another.
We'll start with what's called maximum cardinality, which, as the name suggests, sets the maximum number of connections allowed. And there are really three main types you need to know: one-to-one, one-to-many, and many-to-many. Let's break those down real quick.
A one-to-one relationship is the simplest. Think about your account login for pretty much any website. One customer has exactly one login, and that one login belongs to only that one customer. It's a direct, exclusive, one-to-one link. Simple as that.
Now, the one-to-many relationship is the absolute heart of our e-commerce example. One single customer can place many orders over time, right? But each of those individual orders belongs back to only that one customer. In the notation, the N just stands for many. So, one customer, many orders. And finally, we've got the many-to-many relationship. Let's think about products and orders. A single order can have many different products in it, and at the same time, a single popular product, like a pair of headphones, can show up in many, many different orders from tons of different customers.
So, we figured out the maximum number of connections. That's a huge step. But what about the minimum? Does a relationship have to exist, or is it just optional? This brings us to the other half of the puzzle. When the minimum number of connections is 0, it just means the relationship is optional. A customer, for example, can exist perfectly fine in the system without ever having placed an order. The connection isn't required. But on the other hand, when the minimum is 1, that relationship is mandatory. It's a requirement. An entity can't exist unless it's connected to at least one of the other entities.
Okay, now we put the minimum and maximum rules together. For the relationship between our customer and our order, we actually define 2 rules. From the customer's side, they can have a minimum of 0 orders, maybe they just signed up, and a maximum of many. So we write that as 0, n. But from the order's side, an order must belong to one customer, and it can only belong to one customer, so we write that as 1, 1. This little rule is what makes sure we never have an orphan order that belongs to nobody. It's a critical piece of the design.
All right, we have our things, and we have the rules for connecting them. Now, we just need to actually describe the things themselves. I mean, how do we store the information we care about, like a customer's name or a product's price?
We do this using something called attributes. And there are 2 main flavors. Descriptor attributes are just characteristics, things like a name, an address, a color, a price. But the most important type, the absolute hero of the story, is the identifier, which is also called a key. This is a special attribute that guarantees every single item is 100% unique.
So for our customer, we might have attributes for their name, address, and email. That's great. But what if 2 customers have the same name? To solve this, we need an identifier, like a unique customer ID. This is a number that is guaranteed to be different for every single person, allowing the system to tell them apart with absolute certainty. And with that, we have all the pieces. We've got our entities, our relationships, our cardinality rules, and our descriptive attributes. All the puzzle pieces are on the table. We are now officially ready to assemble the final blueprint.
This visual language is how designers actually draw out these complex data structures so everyone can understand them. Think of it like a cheat sheet. Rectangles are our entities, the main things. Diamonds show the relationships between them, and the attributes are shown as circles, an empty circle for a simple descriptor, and a filled-in circle for that super important unique identifier, the key. It's a standardized notation that lets any developer look at the plan and get it instantly.
And you shouldn't underestimate the power of this simple idea. This isn't just for online stores. This exact same method of modeling entities and relationships is the fundamental blueprint for almost every database you use every single day, from social networks that connect you to your friends to hospital systems connecting patients to their records. It is a truly universal language for organizing information.
So the next time you use an app or a website, you're going to see it differently. You'll start to see the hidden structure, the entities, the relationships, and the rules working tirelessly behind the scenes. You now understand the language of data architecture. So the only question left is, what blueprint will you design next?